Hey everyone, welcome back to Siva Codes. In this video, we are going to solve one of the most important DSA interview problems, maximum subarray sum, also known as Kadane's algorithm. It is a must-known question for FAANG interviews, so let's understand it clearly. Let's go through the problem statement. We are given an integer array nums. Find the subarray with the largest sum and return its sum. First, you have to understand what is a subarray. A subarray is a contiguous non-empty sequence of elements within an array. For example, minus 2, 1, minus 3 is a subarray. 4, 3, minus 3, 4, minus 1, 2, 1 is a subarray. But minus 2, comma, minus 3, comma, minus 4 is not a subarray. Because the 1 is missing, right? It is not contiguous. In order to be a subarray, it should be contiguous. We have to return a subarray whose sum is maximum among all the subarrays which can be produced using the given nums array, right? They are given an example. This is the subarray from which we can produce a sum which is the largest sum among all the subarrays sum which can be produced using the nums array. I hope you got it. Now let's go through the dry run of Kadane's algorithm. Before that, I will explain the intuition behind the Kadane's algorithm. In Kadane's algorithm, we have to continuously add each and every elements in an order in which they are present. So whenever the total sum is becoming negative, we have to replace that total sum to 0. That is the whole intuition behind the Kadane's algorithm. I think you got somewhat right, but I'll try to explain in more detail. Like, take this minus 2. This is the first element, so my total sum would be minus 2. I'm taking 1 as the next element and adding it to minus 1. The total sum would be minus 1, right? Minus 2 plus 1 gives minus 1. So here, upon taking minus 2 as my first element, the total sum is minus 2, right? This minus 2 is changed to 0 according to Kadane's algorithm. Then I am adding that 0 with this 1. So the total sum is becoming 1. Upon two additions, which gives you the maximum sum, the minus 1 or the 1? The 1, right? So what leads to give 1 as a maximum element? Because we dropped the negative total sum and change its value to 0, right? That is the whole intuition behind the Kadane's algorithm. There are two main steps, right? The first step is whenever the total sum is becoming negative, we have to replace it with 0. The other one is we keep on adding the elements coming by, and whenever the total sum exceeds the maximum sum's value, we have to replace that maximum sum with the total sum. That is the two main principles of Kadane's algorithm. Let's go through the dry run over here. The sum is 0 here. The maximum sum is initialized to integer minimum. The value of integer minimum is given over there. This is the value according to C++. So I'm adding this 0, the sum 0 plus the first element minus 2, which gives minus 2. The total sum is negative. So I change it to 0. So I'm comparing the previous value of maximum sum with the total sum. This is lesser than 0. So I'm updating the maximum sum from integer minimum to 0. The next element is 0. The current sum is 0. The next element is 1. 0 plus 1 gives 1. The maximum sum would be 0, which is transformed into 1 because comparing 0 comma 1 gives 1. Here you can see the total sum is again becoming negative. So we are updating it to 0. But you can see here the maximum sum is not updated because no value is greater than 1 has arrived at. So whenever the value like 4 upon adding the next element comes, we can replace that 1 with 4. Upon continuing this process, we get the maximum sum as 6. This is the intuition behind the Kadane's algorithm. Now let's code up the solution. Here I'm declaring two variables, integer sum, which is 0, and max sum, which is integer min, and for n the array is nums, right? Nums dot size. It's just a simple for loop. So I'm keep on adding as the elements come. Two rules, right? If the sum exceeds the maximum sum, we have to update the maximum sum to sum. The next rule is if the sum is becoming negative, we have to put the sum as 0. And at last, we have to return our maximum sum. Let's try to run this. All test cases passed. Let's submit this. Yeah, it is accepted. So the time complexity for the solution is we are using a single for loop. So the time complexity would be order of n. The space complexity would be, I didn't use any extra variables over here like an array. I just declared some and maximum as two variables. So the time space complexity would be order of one. That's all for this video. Thank you guys. Keep supporting.